Good day, students. Welcome to mathgoodserve.com. In this clip, we're going to be going over problems 29 to 32 of the Algebra 1 Common Core New York Regents exam for June 2016. All right, let's take a look at question 29. It reads, Sue and Kathy were doing their algebra homework. They were asked to write the equation of the line that passes through the points negative 3, 4, and 6, 1. Sue wrote y minus 4 equals negative 1/3 times the quantity x plus 3. And Kathy wrote y equals negative 1/3 x plus 3. Justify why both answers are correct. Okay, so first of all, let's determine what the correct answer is, and then we're going to see why both answers are correct. Okay, so you have to remember that there are two formats for writing the equation of a line. You have the point slope form and the slope intercept form. Okay, so Sue's format, this is known as the point slope. It tells you a point on the line and the slope, and this format that Kathy used is known as the slope intercept form. It tells you the slope and the y-intercept. Okay, so let's solve the problem first. We gotta make sure that both answers are correct. So we have the point negative 3, 4, and 6, 1. So the formulas that we're going to use are as follows. Formulas. Let's see, the first one is a point slope form of the equation of any line, y minus y1 equals m x minus x1. And then the second one is a component of this formula, which is the slope formula. The m over here can be determined by computing y2 minus y1, your rise, divided by x2 minus x1, your run. Okay, all right, so let's see. We need x1, y1, x2, y2. So this is x1, y1, x2, y2. Now, formula 1 depends on formula 2 for the slope. So what we're going to do first is we're going to find m, the slope. All right. So m is y2 minus y1 over x2 minus x1, rise over run. y2 is 1 minus y1, which is 4, divided by x2, which is 6, minus x1, which is negative 3. All right, so if we carry out the computation, we'll end up with negative 3 over minus times minus becomes a plus, slash and dash, and you have positive 9. When you reduce these by dividing top and bottom by 3, that's the GCF, you end up with negative 1 over 3 as your m. All right, now we're ready to write down the equation of the line. Right, equation. So we're using the first formula, y minus y1 equals m x minus x1. Okay, so let's see what we have. So we have y minus y1. What is y1? 4 equals m negative 1/3 times x minus x1 minus negative 3. And then that becomes y minus 4 equals negative 1/3 x plus 3. All right, so guess what? This equation, let's see, does it match what Sue has? It certainly does. Y minus 4 times negative 1/3 x plus 3. Perfect. So this matches Sue's equation. So since this does not match Kathy's equation, does this mean that it is that Kathy's solution is incorrect? The answer is no. Okay, this is one form, so we're going to transform into the other form. Okay, so let's ID what form this is. This is the point slope form. All right, which matches Kathy's. Now, Sue's, sorry. So now we're going to transform into the slope intercept form. Okay. When you transform an equation, it's the same thing, it just looks different. All right, so we have y minus 4 equals negative 1/3 x plus 3. Now, how do you do the conversion? All you simply do is you solve for y. Okay, if you get y by itself, then that's going to be the slope-intercept form. On the right side, we can distribute negative 1/3 to these two terms in the parentheses. That yields y minus 4 equals negative 1/3 x minus a third times 3. Okay, so we have y minus 4 equals negative 1/3 x. These 3's divide out, minus 1. Okay, final step, we just add 4 to both sides. So you add 4, and that gives us y equals negative 1/3 x plus 3. And this is the slope-intercept form. Okay? Okay, so we have to write a justification just to tie everything together. So what is our conclusion? Conclusion is as follows. Sue and Kathy's answers are correct. Her, both correct. Why? Well, because if the correct answer is expressed in point slope form, and slope intercept form, you get Sue and Kathy's answers respectively. Okay, you get Sue and Kathy's answers respectively. So it doesn't matter the form. There is exactly the same thing. Okay, so point slope form, we have Sue's answer. Slope intercept form, we have Kathy's answer. Both answers match what we got, so that indicates that they are both correct. All right, let's take a look at question 30. It reads, during a recent snowstorm in Red Rock, New York, Jamie noted that there were 4 inches of snow on the ground at 3 p.m. and there were 6 inches of snow on the ground at 7 p.m. If she were to graph these data, what does the slope of the line connecting these 2 points represent in the context of this problem? All right, so we're going to be finding the slope using the formula. Let's write down the formula first. Slope is equal to y2 minus y1 is equal to divided by x2 minus x1. Okay, don't forget, another word for slope is rate of change. Rate of change. Okay, now let's give ourselves a visual of the situation right here. We're going to graph the 2 points. Now we have 2 ordered pairs. We have 4 inches and 3, and then we have 6 inches and 7. Now, which is the x and which is the y? How do we write our coordinates? Now remember, your x-axis is always the independent variable. Okay? So time and inches of snow, which one do you think is independent of the other? Time is always your independent variable. Okay? Time doesn't depend on anything. Whatever you're doing, time doesn't wait for anyone, right? It just keeps going. So your time is going to be your independent axis, the x-axis. So time of the day, that will be your y-axis. Okay, so let's go by threes. It goes from 4 to 7. Oh, let's go by twos. 1, 2, 3, 4, 5, 6, 7. Okay, and then if this is your time of the day, your dependent y, in this case, let's see, we can just call it I, the I-axis for inches. Okay, so this would be inches on the ground, so inches of snow, inches of snow. All right, now let's go. We have, so we're gonna do, well, how do I know how to calibrate these points? Let me write down the points so you can see exactly what I'm doing. 4 goes with 3, okay? So this is your x, and this is your y. To be more specific, y1, x1, the first ordered pair. So we're gonna graph 3, 4 as your first point. And then the second one, this is going to be y2, and this is going to be x2. Remember, time is the x's, and inches of snow is your y's. All right, so we have, what do we have? 7, 6. Yes. Okay, so when I'm setting up my calibration, I'm looking at 3 and 7. I want to make sure I include those two values. And then for my y-axis, I'm going from 4 to 6. So 1, 2, 3, 4, 5. Oh, this doesn't work. I need to adjust my axis, make it a little bit higher. 4 to 6. 1, 2, 3. 1, 2, 3, 4, 5, 6. Okay. So I'm just giving you a visual. You don't really have to draw the graph, but it helps you visualize what's going on and label your coordinates properly. All right, so we're going from, want to calculate the slope from 3, 4, 1, 2, 3. 1, 2, 3, 4. From here all the way to 1, 2, 3, 4, 5, 6, 7, 7, 6. Bam, right there. Okay, so this is 7, 6, and this is 3, 4. So the question is asking, what does the slope mean? All right, so let's go ahead and find the slope first. You can find the slope by counting, but I like to use a formula. Okay, so the slope m is going to be y2 minus y1 over x2 minus x1. Okay, so you're gonna go y2. What is y2, y1, x2, x1? Let me label it for you so you can see this is x2, y2, the second coordinate, x1, y1, okay? All right, and then we're gonna do y2, which is 7, no, 6 minus y1, 4, divided by x2, which is 7 minus x1, which is 3. 6 minus 4 is 2, 7 minus 3 is 4, which is equal to 2. Okay? No, sorry. It's supposed to be 1/2, which is equal to 1 over 2. You achieve that by dividing the top and the bottom by 2. Now, this is a key. In order to know what this means, what you're going to look at is the units of the y's and the x's. Okay? The y's is inches of snow, and the x's is time of the day. Okay, so we're counting from 3 to 4, so this is going to be in hours, right? Hours, and then this is inches. Well, we already have the unit there. All right, so let's put it in there, inches. So what does this mean? Well, let's just put it, write it next to each other. So then the top, the numerator is the y's, which is inches per hour. Okay, what is slope again? Slope is rate. Okay, so what this basically means is that the rate at which snow is falling per hour over this time interval is 1 over 2. Okay, so let's write down what this means. So it says, what does this represent? The slope 1/2 inches per hour represents what? Represents the rate at which snow is falling over the time interval. What's the time interval that we're looking at? The time interval from 3 all the way to 7. So that's the rate at which snow is falling over this time interval from 3 to 7. Okay, so that's that. All right, let's take a look at question 31. It says the formula for the sum of the degree measures of the interior angles of a polygon is big S equals 180 times n minus 2. So for n, the number of sides of a polygon in terms of S. So we have big S equals 180 times n minus 2. The goal is to solve for n. So we're trying to isolate n, okay, isolate this variable. So how do we accomplish that? What we can do is we can do this in two ways. There are two possible formats for the answer, but what they mean the same thing, okay? So method one, so you have S equals 180 times n minus 2. So what you can do first here, you can divide both sides by 180. Remember, the goal is to get little n by itself. And then that yields S over 180 equals n minus 2. And then you proceed to add 2 to both sides to get n isolated. All right, so your final result will be n equals S over 180 plus 2. All right, so this is one format for the final answer. All right, but there's another way you could do it. The answer looks different, but it's exactly the same thing. For the first method, we divided first. The second method, we can actually distribute first, all right? So S equals 180 times n minus 2. What if we decided to get rid of this parentheses because it's annoying and we want to get the equation looking nicer? So we distribute 180 across these two terms in the parentheses. And then we get big S equals 180n minus 360. Now I said, okay, let's go ahead and get n by itself. We add 360 to both sides, and you have S plus 360 equals 180n. And then you proceed to divide both sides of the equation by 180. Okay, 180. And you have n equals S plus 360 over 180. Okay, and your answer could look like this. These two mean exactly the same thing. If you find the LCD here and combine, you get this. If you split this up into two fractions and reduce, you get that. So it doesn't matter whichever format you express the answer in, they mean exactly the same thing. All right, let's take a look at question number 32. It reads, in the diagram below, f of x is equal to x to the third plus 2x squared is graphed. Okay, also graphed is g of x, the result of the translation of f of x. The question is, determine an equation for g of x and explain your reasoning. Okay, so in order to be able to determine the equation of g of x, we need to remember our transformation functions. We're going to focus mainly on translations here. Okay, if a function is shifted up k units, you're going to have f of x plus k. If it's shifted down k units, you have f of x minus k. If it's shifted to the left, you have f of x plus h. Basically, all the x's will be replaced with x plus that unit value shift to the left. And then to the right h units is f of x minus h. All the x's replaced with x minus the number of units you shifted to the right. In this problem, we can clearly see that In order to go from F to G, you have to shift 1, 2, 3, 4. 4 units down. Okay, so let's go ahead and write this down. G of X is a 4 units shift of the function f of x. Okay, so which of these scenarios is applicable to this problem? 1, 2, 3, or 4? We're shifting down k units. Okay, it's a 4 unit shift. Oh, I didn't indicate the direction, so let me do that. 4 units shift of f of x in the downward direction. In the downward direction. Downward direction. Okay, so we're shifting vertically downwards to be specific. So we are going to be looking at equation 2. All right, so guess what? G of x is simply going to be f of x minus, okay, for vertical shift, you just add or subtract depending on the direction and magnitude of the move. In this case, we're going 4 units down, so we're going to subtract 4. All right, so if you look at the problem, we already know what f of x is, right? So f of x is x to the third plus 2x squared. We replace f of x with its value and we subtract 4. Okay, so g of x is x to the third plus 2x squared minus 4. So this is our first answer, the equation of g. Now we need to explain our reasoning. All right, so let's go ahead and write that down. So the equation of g of x, the equation of g of x is equal to x to the third minus 2x squared minus 4 because it is generated as a result of doing what? As a result of shifting the original function f of x equals x to the third plus 2x squared 4 units in the downward direction, or 4 units downwards, okay? Downward direction. So when they ask you to explain, all you just have to do is explain your work. Just contextualize it. Just put it in word form, and then you should be good, okay? So this is basically the explanation as to why this equation is a representation of g of x. Thank you so much for taking the time to watch this presentation. We really appreciate it. If you find the contents of this tutorial helpful in your preparation or review of your Algebra 1 Regents exam, do give us a thumbs up. Your positive feedback is very important to us. Any questions or comments, just include it in the comment section below, and we'll be glad to provide you with needed support. Don't forget to subscribe for updates to the remainder of this review series. More clips can be found on mathconserve.com under test prep. Thanks again for watching and have a